Hi guys. In this video, what we're gonna be doing is, this is kind of a review, and I'm mostly gonna be reviewing how to write, basically quadratic functions, equations, and inequalities, but, I just want to make this video to kind of, review how to do this stuff and basically writing quadratic functions given 2 points, etc. Everything about quadratic functions mostly. It's a very quick review. So let's get started. So this first question that we have here, and this is, by the way, this is for algebra, if you're in algebra, college algebra, or beginning algebra, depending. This is for, this is kind of the review for that. So, what we're going to start with first is writing a quadratic function given 2 points, one of which is the vertex of the parabola. Now, we have this question here, and it says, determine the quadratic function whose vertex is 2, 3. Let's see. Okay. And crosses through 5, 2. So we want to know a function f of x that has the vertex 2, 3 and crosses through 5, 2. And yes, this is possible to do. But I would say the only thing is actually, and let me go ahead and try to, because I don't know, I'm not 100% sure if, and I think, honestly, I think it is, because, since the vertex is, basically what I'm trying to say is that it's going to be a parabola going upward. And at first I didn't know if that was what it was going to be, but yes, it's going to be a parabola going upward because you have the vertex at 5, 2, right? And it goes through a point 2, 3. So basically, this is the other point, if you think about it. So if we kind of do a little diagram here, we have, 5, 2 here, and 2, 3, right? And we want to know, what is this parabola, right? And it's not a perfect sketch, but we want to know what that parabola is. And by the way, guys, if I haven't been uploading, it's because I've been trying to get rid of, I'm finally done with finals, so that's why I haven't been uploading. Okay, so here, we have obviously the equation of a quadratic in vertex form is a times x minus h squared plus k. And the vertex is 2, 3. That means that hk is equal to 2, 3, right? Now we can say that f of x equals a times x minus 2 plus 3, right? However, you're wondering, well, what is a? What is our a value, right? We still have to find our a value here. And I'm going to do a few of these, by the way. But anyways, we have to find our a value. And let me just make sure it's okay. So here, the way that we do this is, because we know that f of 5 is 2, that means that when x equals 5, y equals 2. So that means that, well, yeah, that basically means that, f of 5, basically that's y equals 2. We can plug in, we can say f of 5 is equal to a times the quantity 5 minus 2 plus 3. Now, we know that f of 5 is 2 because obviously when x equals 5, y equals 2, so we can plug that in for f of 5. 2 is equal to a times 5 minus 2 is 3 plus 3, right? So we have 2 equals 3a plus 3. We go ahead and subtract 3 on both sides. We get negative 1 equals 3a, right? And so then a is negative 1/3, right? So therefore, our function is f of x equals, and we have our a values, so in vertex form it would be negative 1/3 times the quantity x minus, and we have our h value, that's 2 plus 3. And you can verify this. Oh, and it's going to be squared, by the way. I know that I put it's squared plus 3. Yeah, my bad. It's squared because it's not a linear function. It's a quadratic, so it's squared. So it's going to be negative 1/3 times x minus 2 squared plus 3. And you can verify this with a calculator or with Desmos. We can verify that very quickly, so give me 1 second. Okay, so on Desmos, we had said that the 2 points that the parabola goes through are 2, 3, which is our vertex, right? And 5, 2, right? So we have 5, 2. And we can verify that the quadratic function for which, where the vertex is at 2, 3, because obviously whatever the vertex is and whatever second point you have here, that's going to determine whether your parabola is going up or down. So because here our second point is 5, 2, right? And our vertex is 2, 3, the parabola is going to be going downwards, okay? Because this is our second point. If the point were going like 5, 4, then it would be going up. Because obviously any point that's after your vertex, like to the right of your vertex, determines if it's, if it's higher than the original point you had or lower than the original point you had. Well, yeah, basically that determines what your parabola, like if it's going to be going up or down, pointing upwards or downwards. So anyways, so we can verify negative 1/3 times the quantity x, and it was x minus 2 squared plus 3. Oh, and actually, hold on. Five, 2. Negative 1/3 times x minus 2 squared plus 3. Interesting. Okay. Give me 1 second, guys. Hold on. Okay, I'm sorry. I know what I did wrong. I just caught it. Oh my goodness. So here, my bad, guys. Here, it was supposed to be squared plus 3. So then we have a times 3 squared plus 3. And then, basically, we would have... Oh my goodness. It would be 2 equals a times 9 plus 3, which is 2 equals 9a plus 3. So then negative 1 equals 9a over 9, and then you have a is negative 1/9. So the parabola would actually be f of x equals negative 1/9 times x minus 2 squared plus 3. And like I said, you can verify this. Sorry about that, guys. Oh my goodness. Yes, there we go. You see, there we go. You see how it goes through 5, 2 and 2, 3. The vertex, which is the peak point, is 2, 3, and it goes through 5, 2. Okay, so let's do another example of these. I kind of messed that one up a little bit at the end. But yeah, the main what is it called? The main goal here is you have to use the vertex form of a parabola and use to basically write it in vertex form without the a value, and then once you to figure out what a value you have to plug in your sorry guys. Anyways, so after you do this, basically you just have to find your a value, and once you find your a value, you do it by plugging in the second point, and then you have your a value, and that's how it's done. We're gonna do another example though. So let's see. Let's just say, and let me go ahead and try to make up another example very quick. Okay, so let's just say that we want to write a parabola, a quadratic function whose vertex is negative 1, 2, and you do the second point would be it crosses, or basically goes through 1, 4, right? And you want to figure out what basically what is the equation, what is the function of the parabola, right? So we're going to go ahead and write our formula again for the quadratic function, the vertex form. And so again, what you're going to do, you can say y equals, if it helps, y equals a times x minus h squared plus k. However, when you do that, you want to also say, you want to write it in both ways because it just helps. So basically, they're saying that our vertex is negative 1, 2, right? We're going to say f of x is equal to a times the quantity x minus, and again, the vertex is hk, right? So we're going to say x minus negative 1 squared plus 2. So it's going to be f of x equals a times the quantity x plus 1 squared plus 2. And we have f of x equals, so basically this is what f of x is. It's going to be x plus 1 squared plus 2, right? So then they're giving us a point here. Our point is 1, 4, right? So x equals 1. basically we have 1, 4, x equals 1, y equals 4. So we can say f of 1 equals a times the quantity 1 plus 1 squared plus 2. And we know that f of 1 is 4 because when x equals 1, y equals 4. So it's 4 equals a times 2. Oh god. Sorry guys, give me a second. A times 2 squared plus 2, right? So then we have 4 equals a times 4 plus 2, right? And we can say 4 equals 4a plus 2. So then we go ahead and we subtract 2 on both sides, right? 2 equals 4a. We divide by 4 on both sides. A is 2/4, and when we reduce that, we get a is equal to 1/2, right? So, so then we know that a is 1/2, and we know we already have basically everything else written. Now we have our vertex and everything. So now we can say that our function is f of x equals 1/2 times x plus 1 squared plus 2, right? And again, we can verify this when we plug in, I think if we go back on Desmos and we say that our vertex is, so basically our vertex is negative 1, 2, right? And then our point, it goes through 1, 4, right? And we can verify that this is our quadratic function. It's going to be 1/2. So we have, and let me just make sure that I actually did it right this time. Okay. Okay, yes, I did. Okay. So 1/2, we can say that we have 1/2 times the quantity x minus, or sorry, x plus 1 squared, right? And then plus 2, right? And as you can see, these 2 points that I put before are actually shown. They're the ones that go through the parabola. So that's just how it works. And this isn't, this isn't something too difficult if there's something that, like, you really just have to pay attention to, like, what your vertex is and what your second point is. Remember I said that if your second point is lower than your vertex, meaning that, let's say, if instead of our second point being 1, 4, let's say it was like 10, -1 or something, then that would mean that on the Cartesian plane, which is on the xy axis, if the second point is lower than the vertex here, then that means your parabola is going to be going downwards. If it's higher than your vertex, because right here our point is higher than our vertex, it's going to go upward, okay? So I hope that helps, guys. That was a very quick review of this. In the next video, what we're gonna do is basically graph quadratic functions and also, you know, maybe also do quadratic equations. I don't want to make this video very long, so that's why I'm kind of ending this part here. But in any case, I hope that helps, guys, and I will see you guys in the next video. Bye, guys.